Hi guys, welcome to lesson of partial differential equation. So in this class, we are going to discuss the construction of solution for non-homogeneous wave equation with time-dependent boundary conditions. So in general, we know that the wave equation is given by utt minus alpha squared uxx is equals to some function of x comma t. All right. Function of x comma t. All right, and the boundary conditions are given in this form: a of t u l comma t is equals to b of t. This is type 1, that is Dirichlet. Number 2, we have Newman conditions, right? And then we have mixed boundary conditions, and we have two cases in mixed boundary conditions. Number 1 is ux0 comma t is equals to a of t, and u at l comma t is equals to b of t. And then we have u 0 comma t is equals to a of t, and ux l comma t is equals to b of t. So if an equation is given with the boundary conditions, then we know that for these type of equations, we have the solution of the form wx comma t plus vx comma t, where this wx comma t is a solution satisfying the boundary conditions, right? And then v of xt is equals to u of xt minus w of xt. So in this way, we split the problem into two parts to solve for w and v, right? So let's talk about some specific boundary conditions. So here we have some boundary conditions. Number 1, that is Dirichlet. If Dirichlet boundary conditions are given in this form, u0 comma t is equals to a of t and ul comma t is equals to b of t, and then the solution of wx comma t is given by a of t plus x over l times b of t minus a of t. All right, so we will take some examples after this discussion in order to get more concepts. Then for Newman boundary conditions, we know that these are the derivative boundary conditions. ux 0 comma t and uxl comma t is given. Then we formulate wx comma t in this way: x times a of t plus x squared over 2l times b of t minus a of t. Right, then for mixed boundary conditions, for type 1, we have u of 0 comma t is equals to a of t and uxl comma t is equals to b of t. So in this case, we formulate w of xt in this way: a of t plus x times b of t, right? And then for type 2, when the first one condition at 0 is the derivative, that is ux 0 comma t is a of t and ul comma t is equals to b of t, then we formulate w of xt in this way: that x minus l times a of t plus b of t, right? So let's take some examples to understand the phenomena. Here we are given with the boundary conditions. These are Newman conditions. So for Newman conditions, here we can see that this is a of t and this is b of t. So these are the time dependent boundary conditions, right? So in this, here we can see that an L is equals to pi. This is L. Right, so L is equals to pi. Then we have the formula wxt is equals to x times a of t plus x squared over 2l times b of t minus a of t. Here we plug the values: x times a of t, that is cosine t minus 1, plus x squared over 2 times L. So for L we plug pi, times cosine t minus cosine t plus 1, right? Because this is b of t and minus a of t. So here we got the solution for wx comma t. Now let's talk about this example. Let's say that if u of 0 comma t is equals to t squared and ux of pi comma t is equals to 1, these are the mixed type boundary conditions, right? Mixed boundary conditions. So, and we can see that the first condition is normal and the second condition is derivative. Therefore, we use this formula to construct the solution for wx comma t, that is a of t plus x times b of t. A is given t squared, this is a, this is b, b is equals to 1, l is equals to pi, so wx comma t is equals to t squared plus x. So this is the solution for wx comma t to this specific boundary condition. Now if we have the boundary conditions here, we can see that these are the Dirichlet conditions. U of 0 comma t is equals to e to the power t, and then u of 2 comma t is equals to t. Therefore, wx comma t is equals to a of t plus x over L times b of t minus a of t. A of t is given as e to the power t, b of t is equals to t, and L is equals to 2. We just have to plug the values in this equation, and we will get the solution for wx comma t in this form, right? So this is the idea for constructing the solution for wx comma t for the specific type of boundary conditions that we are dealing mostly in these type of equations. Then we know that once we have the value of wx comma t, that is some function of x comma t, then what we do, we simply have to formulate the vx comma t, which is equals to ux comma t minus wx comma t. And then from here we can see that vtt minus alpha squared vxx is equals to utt minus alpha squared uxx minus wtt minus alpha squared wxx. So in this way we can find the equation for this v of x comma t, and then we will use the boundary conditions like this: u of 0 comma t minus w of 0 comma t. Then for v of l comma t is equals to u of l comma t minus w of l comma t. All right, and for initial conditions, v of x comma 0 is equals to u of x comma 0 minus w of x comma 0, and for vt of x comma 0 we have ut of x comma 0 minus wt of x comma 0, right? This w we already have in the solution. Here we formulate using the boundary conditions. So this is the idea to solve the non-homogeneous wave equation for time-dependent boundary conditions, right? So these are very important for solving non-homogeneous equations. All right, so that's all for the time being. Thanks for watching the lesson.